today's section 5.5, using triangle congruence. Like I said, you've pretty much already learned this. The very first thing we did this chapter was we said if we have these sides and angles that are all congruent, so the triangles are congruent. Now we're doing the converse of that, saying, okay, if the triangles are congruent, then all their parts are congruent. Okay? So I want you to write that right at the top, because that's the key to this section. If triangles are congruent, then their corresponding parts are congruent. So the parts that match up, the angles that match up are congruent. The sides that match up are congruent if you know that the angles, or if you know the triangles are congruent. So in the diagram, AB and CD bisect each other at M. Prove that angle A is congruent to angle B. Okay? So to start this, I am going to draw two columns. I'm going to label statements and reasons, because that's how we start off a proof. And what is step one every single time? The givens, right? Okay, so here we go. Statements, reasons. Okay? And what we're trying to prove is going to be the last thing in our proof. Angle A congruent to angle B. We're not sure how many steps it's going to take us. We're not sure what the middle steps are going to be at this point, but we know that that's what we are working toward. So in the givens, did they tell us that angle A is congruent to angle B? No. So what we have to do first is show that the triangles are congruent so that all their parts are congruent. So then the step right before that is going to be that the triangles are congruent. So triangle AMD congruent to triangle BMC. Do you have to do it in that order? No, as long as they match up. So because we want the angles congruent, we have to have the triangles congruent. Nick, get the earbud out of your ear, please. Okay, so now let's use the givens to mark the figure with anything that we know. AB and CD bisect each other. What does bisect mean? Cut in half. So they cut each other in half. That means that AB cuts CD in half. So CM and DM are going to be congruent. And CD also bisects or cuts in half AB. So that means that AM is congruent to BM. Why? Because bisectors cut in half. And there are much more technical ways to describe that, but in your own words, if that makes sense to you, bisectors cut in half, perfect. As long as I know what you're talking about. And I always tell you, after you mark your givens, mark anything in the figure that you can. So what in this picture can we mark? Vertical angles with the vertex M, right? So these two angles are congruent. We cannot just say angle M congruent to angle M because there's more than one angle there. So we have to use three letters. I'm going to say angle AMD congruent to angle BMC. And why did you guys say that those angles are congruent? Why could we mark those? They're vertical angles, so vertical angles are congruent. think I just spelled that wrong. So I was trying to write and talk at the same time. Is there anything else that we can mark? Yep. Next step. Do we have enough to prove triangle AMD congruent to triangle BMC? Yes. Why? Side angle side, right? Now that we know the triangles are congruent, we also know, even though it's not marked, we know that angle A is congruent to angle B, because if triangles are congruent, notice I am abbreviating here, then their parts are congruent. Okay, now we're going to look at example 2. Sketch the overlapping triangles separately. Mark all congruent angles and sides, then tell which theorem or postulate you can use to show the triangles are congruent. So let's take this one step at a time. Let us take a look. We have two larger triangles here. Here's one, and I'm just going to outline the other one. Here's the other. Yes? We have two triangles that are overlapping, so what we're going to do is we're going to unslide them, basically. We're going to slide them apart and draw two separate triangles. So here would be the blue triangle with its markings. Notice I put the single arc there at H because there is a single arc down here at H. My drawing is obviously not to scale.
Wait, is there one in G?
There's also one in G, yes.
Is it not for the other triangle?
It's not because it's only part of the angle at G. In the other triangle, in the blue triangle. Good question. Okay, so now, what else can we mark? What else can we mark? Before we began, what we could have done, you don't have to, but what you could have done is you could have say, well, GH is in both triangles, so I'm going to mark that congruent by the reflexive property. But even if you didn't do it then, you could look at these two triangles and say, oh, well, we've got GH here, and we've got GH here.
Isn't GH congruent on the other side?
On the other side? What do you mean?
Like on the other GH that isn't marked?
Over here?
No, like
Congruent, so why are they congruent? Angle, angle, side. The side is not between the two angles. That's why it's not angle, side, angle. All right. Follow-up. We are going to skip that first one, but I want you to redraw the second one. So take those two larger triangles apart and sketch them separately. Triangles. So since BC is in both triangles, we can mark it congruent. In this picture, it could be congruent by the reflexive property. Really, in this picture, that is it. There's no other markings or shared items, so that's all you should have. All right, example number 3. This is why we did not do the first one in the follow-up, because this is almost the identical picture that we're going to do now. So, in the diagram, CB is congruent to CE. Let's go ahead and mark it. And angle DEC is congruent to angle ABC. Hang on just a second. So before we even begin the proof, because it's asking us to prove, I want you to sketch the two triangles separately. So to start any proof, we need 2 columns. We need our givens listed, and we already have the givens marked, both in our original picture and in the picture that we separated. We want to work toward these 2 segments being congruent, which is not marked currently because we don't know that it's true. We have to show that it's true. So before we could show that their parts are congruent, we have to show that the triangles are congruent. So the step right above that is going to be to show that the triangles are congruent. So triangle, ABC, and you can do this in any order, congruent to what matches up,
Wait, should we like leave a space under that?
DEC. Yes, I would leave some space in between, because we're going to fill in the steps. Okay, so if we want to, look, yeah, it looks like sleet or rain or something. Snowing? Hang on.
Anything else?
Hang on. 5 ways to prove triangles congruent. Remember, side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. We have an angle. We have a side. So we need another piece of information. This is not a right triangle, so we're not going to use hypotenuse, leg. We're not going to use side, side, side because we have an angle. So the question is, what else can we mark on these figures?
I feel like
What is shared?
the C.
Yeah, the C is in both, right? So C can be congruent to itself by the reflexive property. So angle C congruent to angle C. Why? Reflexive property. That's enough to show that the triangles are congruent, so we can now put a 3 by this. They are congruent by which theorem or postulate? Angle, side, angle, because the side is between the 2 angles. So then we know the segments are congruent because if the triangles are congruent, their parts are congruent.